Continuing our adventures with electrochemical stoichiometry. It's a mouthful. Once again, we're given a redox reaction of some kind. We have to figure out what the balanced reaction is and then do some stoichiometry with it. In this case, they start us with a chunk of silver. Silver metal is just Ag, is reacted with acidified. That word automatically means hydrogen ions. Solution probably means H2O. We could throw that in. Even acidified also implies the presence of water a lot of the time. K2Cr2O7 is potassium dichromate. Potassium solutions are super soluble in water. K washes off easily if you want to think of it that way. So we're going to get potassium ions there and dichromate ions. And I guess that's all the stuff. So if we go to our redox table, looking for our SOA and our SRA, we find 1, 2, 3, 4, 5, 6, 7. The 8th line down on our redox table is acid dichromate. Hydrogen and dichromate working together are our strongest oxidizing agent. And their reaction is Cr2O72 minus plus 14 hydrogen plus, lost my line, 6 electrons. 2 chrome 3s, and 7 water. It's technically wrong to say chrome. You should say chromium all the time. Sorry, I do that sometimes. I hope it's not confusing. Okay, so our SOA is acid dichromate. Our strongest reducing agent, I have a feeling it's got to be the silver, but let's pretend we don't know and look. Looking up the right side, we have silver, potassium, ions, dichromate, water. Yeah, it's completely silver. Okay, silver metal is our strongest reducing agent. It will do the opposite of what's written in the book and turn into a silver ion and 1 electron. We want to combine these. We can't because the electrons are out of whack, so fix that. This reaction is fine. We can leave it at 6 electrons. We'll multiply the silver reaction by 6. And now that they both have 6 electrons, we can throw out the electrons and add together what remains to get our balanced reaction. Cr2O72 minus plus 14H plus 6 Ag, 2 chromium 3 plus 7 water plus 6 silver ions. Okay, that's our balanced reaction all ready to do stoich with. And they tell us, now watch out here, they say they start with 5.9 grams of silver and they throw that into acid dichromate and a reaction happens. It isn't obvious until you get to the question that not all the silver got used. They say what mass of silver reacted. So what that implies is the acid dichromate is what runs out. And at that point, we've used up some of this silver, but not all of it. We could turn this into a limiting reactant problem if we really wanted to check that and make sure it works, but just from the wording, you can kind of tell they mean not all the 5.9 was used up. So we cannot put 5.9 grams under the silver. We're going to have to start with the dichromate. They give a volume of 35.9 mils for the potassium dichromate, so I'm going to say our volume here is 0.0359 liters, because you divide by 1,000. This is 1-to-1 because a single K2Cr2O7 gives us 1 Cr2O7 ion. If we were talking about potassium, I'd have to multiply by 2. It would be a 2-to-1 ratio, but there's only 1 dichromate in a potassium dichromate. And our concentration is 0.2 moles per liter. 0.2. We'll be good about sig digs this time. Moles per liter. Okay, well that's exactly what we need to get a number of moles, so let's get after that. N equals CV equals 0.2 times 0.0359 is 0.00718 moles of dichromate ion. And they want to know how much silver went with that. Silver's over here, and the ratio of them is 1 to 6. So take this number of moles, multiply by 6, and we get the moles of silver involved would be 0.04308. We want the mass of silver. Mass is number of moles times molar mass. Number of moles, just found it, 0.04308. Silver's molar mass is 107.87. Calculator is punched, and we get 4.6470396 grams of silver. Sig digs, how much of this do we get to keep? We never used this 5.90, so do not look at that. This has 3 sig digs, that has 3 sig digs. It's all 3, isn't it? Yeah, my molar mass had 5, but everything else had 3 sig digs, so 3 is what we get to keep. So out of all this, we get to trim down to 4.65 grams of silver is what got used up. We started with 5.90. This much of it reacted, and then there would be, 1.25 grams of silver left over.